Hello guys, welcome back to my YouTube channel. In this video, we will be implementing clamp circuits in Proteus. So let's start by learning a few things about clamp circuit. Here we have a positive clamper and negative clamper. Okay, now what is a clamper circuit? In clamper circuit, as the name suggests, output wave is clamped, or in easy words, we provide an offset through the circuit. It will have no impact on amplitude, frequency, and other factors, but the wave will be clamped. Here we can see the capacitor is attached to a reverse bias diode along with the RL load resistor in parallel. That is for positive clamper. In negative clamper, we only change the direction of diode from reverse bias to positive bias, forward bias. We can see the difference between input waves and output waves. The starting level is 0 and here it is Vm. For negative clamper, it starts from 0 and goes to the minus Vm. The DC level decreases. Well, there's slight change in a negative clamper with positive bias or positive clamper with positive bias. We provide an additional 5V voltage or 2V as much as we require. Now let's move to the construction of the circuit. Overall, it consists of a diode, a resistor, and a capacitor. For diode, we will use a simple generic diode. Using wire, we can make all the required connections. For a positive clamper, diode will be placed in a reverse bias position and vice versa for negative clamper, and can also add a battery with diode to make a negative or positive clamper with bias. Now if we run the circuit, we will get our required outputs. Now you can see here I have applied V sign. Now if you want to pick one like this, you can go to the generator mode. Here we have DC voltage, we have sine voltage. If you want sine voltage or pulse or DC, you can apply directly from here. Sine, just place it like this, sine, and then apply amplitude like 5, and it's ready to be connected. For capacitor, we have used 4.7 microfarad resistors of 1000 kilo ohms. Our input wave is of yellow color and output wave is of blue color. So now let's compare both of them. Now this is our resulting output wave. Now if you guys remember, normally there are 1, 2, 3 and 4 boxes. The distance between the two waves is 4 boxes, but now there is 3. That shows the output wave is clamped one box above, which shows our output is correct. Now if we place the diode with forward bias configuration, we'll have the negative clamper. That means the wave, the DC offset will be negative. So let's go to the here. Now as I said, if we place the diode with forward bias configuration just like we did here, and the other components will have the same, like 4.7 microfarad, 100 kilo ohms, and a simple generic diode. Same voltage, same oscilloscope, same wire connections. There's nothing much difference here. Now let's compare the outputs here. The last one, the one with the forward positive clamper, there was a difference of 3 boxes, but now here are 5. That means the wave is negative clamped, which shows the negative clamping of the wave and also shows that our output is correct. Now we can stop the output here. Do not, if you run here, do not cross it from here, just stop it from here or press escape from your keyboard. Double. Now also, if you want to copy this, you can just select it and right click here or here. Mm, Here's the PCB layout, your schematics capture and 3D visualizer. If you want to go use any of these, you can just click here. Oscilloscope is placed from here. Hmm. If you want more tutorial videos like this, subscribe to this channel and give this video a huge thumbs up. I'll be uploading more tutorial videos to analog related to analog electronics in coming days. Till then, I'll see you guys in the next one.